1, Lesson 12, we're going to focus on solving equations. So our instructional outcomes are to solve equations and explain each step as following from the properties of equality, and 2, to identify equations that have the same solution set. So when the class started, in the opening exercise, the teacher posted these 4 different statements. We'll look at one at a time, starting with letter A. And now the goal here was for the students to look at each equation, determine what is different, what property, commutative or associative, and then would each equation have the same solution regardless of the changes that were made. So in part A, why should the equations for x minus 1 times x plus 3 equals 17 plus x and x minus 1 times x plus 3 equal x plus 17 have the same solution? And so what we're looking for the students to identify is the only difference in the two equations is the 17 plus x and x plus 17. Noting from previous information that whether, for example, if you had 4 plus 3 equals 7, or if you ended up with 3 plus 4, that's equals 7. Students make the connection that whether it is 17 plus x or x plus 17, we are looking at the same solution for the equation. And then the students would say that is represented by the commutative property. Next, the teacher showed part B. Why should the equations x minus 1 times x plus 3 equal 17 plus x and x plus 3 times x minus 1 equals 17 plus x? So after looking at it, the teacher and the students will note that this part and this part is different. The only thing that is different is the x plus 3 and the x minus 1 is swapped in terms of its role. So again, it's designed to relate the design that 4 times 3, for example, equals 12 versus 3 times 4 also equals 12. For what reason? Again, same thing, commutative property as an explanation. In part C, do you think the equations x minus 1 times x plus 3 equals 17 plus x and x minus 1 times x minus 3 plus 500 equals 517 plus x should have the same solution set? And so what the students observe in this scenario is that the only difference is we added 500 to both sides. Where did the 517 come from? It's 17 plus 500. So this is the equality property of addition, where we added the same number on each side, and thus that is going to allow both equations to maintain the same solution set. And then finally, in part D for the opening exercise, we have 2 more equations. The x minus 1 times x plus 3 equals the 17 plus x again, but this time the change is 3 times x minus 1 times x plus 3 equals 51 plus 3x. What are the students observed having been done here is we are taking and we are multiplying by 3 on both sides of the equation. Where does the 3 come into play here? If I was to take the 17 plus x and multiply it by 3, 17 times 3 is 51, and 3 times x is 3x. So then again, we're looking at the equality property, but this time, instead of addition, of multiplication. So in other words, if I multiply by the same thing on both sides of the equation, I can be ensured that the solution to both equations will still be the same. So going further into the lesson, the students have an opportunity to practice solving for some equations. So in part A, we're going to look at a proportion. And And in proportion, a student needs to recall that they're going to cross multiply what they see. And so then 2r times 1 is 2r, and 3 times 4 is going to be 12. Here we have a one-step equation, and so then we will divide both sides by 2, and so r will equal to 6. In part B, we note that s is squared, and so it's important to note that to undo a square, you're going to need to take a square root of both sides. Now, do keep in mind, we do need to isolate the variable first. So looking at this, we'll need to subtract 5 on both sides. That's going to give us s squared equals 25. And so now I can undo my square with a square root on both sides, going to allow this to cancel. And so part of my solution is going to now be s equals, and initially we're going to put 5. What is important for the student to note, as taught in a previous lesson in this series, that if I take the square root of both sides, there's going to be two solutions. The positive solution, which is equal to 25, versus the comparison that negative 5 times negative 5 is also equal to 25. So the students need to put a plus or a minus in front of it to account that both positive 5 times positive 5 equals 25, and negative 5 times negative 5 also equals 25. In part C, one thing that we're noting that's important to observe is that there are variables on both sides. Now, for a problem like this, it is up to the student if they want to move all the variables to the left or they want to move all variables to the right. For consistency, I'm going to move the variables over to the left. So I will subtract 5y on both sides. That's going to yield me with a negative 1y minus 3 equals negative 8. The next thing is I'm going to add 3 to both sides. And so negative 1y equals negative 8 plus 3 is negative 5. And then the final step is we will divide both sides by negative 1. And so y will equal to a positive 5 in value. The last piece in this lesson that students will work on is to be able to take a given equation, considering 3x plus 4 equals 8x minus 16. And we want the students in small groups to be able to solve for x using the given starting point in each column in the table. So for example, in group 1 it says start by subtracting 3x on both sides. Group 2 is going to say start by subtracting 4 on both sides. Group 3 will say subtract 8 on both sides as your starting point. And group 4 is going to say, well, let's start by adding 16 on both sides. The point of this opportunity of this drill is for students to get a deeper understanding that regardless of where I start in my equation, my x value at the very end of the process is going to be the same. So one thing that I might recommend you do at this point would be to pause the video and try solving group 1, group 2, group 3, and group 4. And then finish watching the video and see if your work matched up in the same way. So if we took a look at group 1, that is 3x plus 4 equals the 8x minus the 16. So they're saying they want us to subtract 3x on both sides first. So we'll put minus 3x here and minus 3x here. 3x minus 3x is 0, it cancels out, so here we have 4 equals 8x minus 3x is 5x minus 16. Then I can take and add 16 to the other side. That's going to allow 4 plus 16 to equal 20. Left over on this side, on the right hand side, is 5x. And so if I divide by 5 on both sides, then I can conclude that x is going to equal to 4. Now, a lot of times the teacher may model group 1 with the students and then say, now here's the understanding and the goal, that for the other 3 groups the answer is also expected to be x equals 4. The advantage this gives the students, it gives them a target. It lets them understand that if they don't get 4 at the end of a process, then they need to go back and they need to revisit that problem and find their mistake, converse with a partnering student in class or whatever to get some additional help. So if we follow it into group 2, it says they want us to subtract 4 from both sides. So again, we start with the 3x plus the 4 equals the 8x minus the 16. If I want to subtract 4 on both sides, I can start by doing minus 4 and then minus 4. And so then when I subtract, I will keep the 3x. The 4 minus the 4 is 0. My 8x comes down, and then negative 16 minus 4 is negative 20. So at that point, I may consider subtracting 8x on both sides. And so then 3 minus 8 is negative 5x equals, and here's what you want to be careful on, this minus sign or this negative goes with the 20. So when you bring it down, you want to bring down a negative 20. It is a common mistake for students to accidentally forget to bring the negative down, and will inadvertently cause them to get the wrong answer just ever so slightly. But again, that's kind of the purpose of this drill. If a student forgot to bring that negative down, they try to do positive 20 divided by negative 5, they would realize that, wait a minute, my answer is not supposed to be negative 4, the answer is supposed to be positive 4. So here we get x equals a positive 4, which is what we want. In group 3, again, we will start with the 3x plus the 4 equals the 8x minus the 16. And so in the instructions they tell us, well, we want you to start by subtracting 8x on both sides. So we can minus 8x minus 8x. And at that point, 3 minus 8 is negative 5x. We have plus the 4 equals the negative 16. So if we continue solving at this point, we will subtract 4 on both sides. So negative 5x equals negative 20. Note the similarities between group 2 and group 3. So I can divide by negative 5 on both sides, and as a result, x will again equal 4. As it should. That is the purpose of this exercise. In the last part, again, we will write down our 3x plus our 4 equals our 8x minus our 16. They want us to start by subtracting or adding 16 on both sides. So we start with plus 16 and plus 16, always being careful to line up like terms. And so we keep our 3x. 4 plus 16 is a positive 20 equals our 8x. So the next step we would need to do is to subtract 3x on both sides. That's going to yield us a 20 equals 5x. And so if I divide by 5 on both sides, then I can conclude for group 4 that x will also equal 4. And so this is a good exercise. This can be done with any equation that you want. And so I would encourage you to try and find another one that that you may want to do this with. Break it up into groups 1, 2, 3, and 4 and see if you can get the same solutions for each one of those given pieces as well. If you need more more support or help, as always, please contact your child's teacher, and he or she will be more than happy to point you in a direction or to provide more support.